In this tutorial, we're going to look at how we define glazing in the zebra model. Now, glazing can be a bit more complicated than other aspects. This is because we have a source of heat loss through the glazing and the framing material, and also because we have solar gains through the windows, and we need to capture inputs that reflect all these aspects. So this is the glazing sheet on the zebra model. If you scroll over to the inputs, you can see we start with two inputs about the properties of the glass. So we start with the U value, which reflects the thermal losses we'll have through the glass, and then the G value, which reflects the amount of sunlight that will get through the glass. So we've given some default values here, so we'll say we're going to use triple glazing and use a default value of 2 for the U value, and then for the G value, we'll use a value of 0.6. After you've input those two, you need to input your glazing sets. So a glazing set can either be a single window or it can be a set of windows with similar properties. So generally, if the group of windows is the same in terms of their framing and their shading level, you might group them into one set just to save time with inputs. So for each glazing set, we start by giving it a name. Then we indicate which wall, door, roof element the glazing is inside. So this list will be populated from the values we've input already into the walls and doors tab, and also into the roof tab. So we can assign a glazing element either to a roof element or to a wall or door element. The next 4 entries are the properties which reflect the geometry of the window. So we start with the glazing area, which is the area of the glass itself. Then we have the frame area, the area of the framing material. The perimeter length, which is the area of the boundary around the window frame, that is. And then the length of the glass frame divider, and this is the total length of the interface between the frame and the glass. So the reason we need these values is because the glazing area is where we will use the U value for glazing, for thermal losses, and it will also give us an indication of how much sunlight will come through. The frame area is where we will use a typical U value for framing material for thermal losses. And the perimeter and the length of the glass frame divider are needed because we have thermal bridges both around the perimeter of the window and at the interface between the glass and the framing material. So with these 4, the software has what it needs to calculate total U value for the window as a whole, including all aspects. Then we have the permanent shading, which is shading from hills or surrounding buildings, and then temporary shading for heating and cooling, which is things like roller blinds we might have to offer shading in the summer, but roll them up in the winter. And then we have the number of the window sets. So the easiest way to explain this is probably by example. Most of these are fairly simple. These are the 4 complicated ones, really, but we do have 2 tools here which help us to determine these values. But we'll go through an example and we'll define windows on the north facade. Choose the north facade here. And then we will get these 4 properties. Now I've explained what those properties are, so you can calculate them yourself if you want, but we have 2 tools to make that easier. The first one is a general tool for a rectangular window, and the second one is a simplified tool. If you don't have a lot of window details, you can just use pictures to take a typical similar looking window and use values for that. So we'll start with the general tool. This takes us into the calculator sheet. And then you can see in this tool, we can define the geometry of our rectangular window. So we can start by defining a hole width of, let's say, 1.5 meters, then the window height of 1.2 meters, and then the width of the framing material, so we'll say 10 centimeters, and the divider width we'll say is 7.5 centimeters. Then we have the number of horizontal dividers. In our case, we're not going to have any, but we will have 1 vertical divider. And based on those values, it will provide you with those 4 parameters, which we can copy and then paste special back into the Glazing tab. So that's a tool you can use if you have some information about the window. If you have even less information, you can use our simplified tool, which again takes us back to the calculators tab. And this just gives us a series of photographs of windows. And you can just choose one that looks similar to the window you have in mind. So you can take the letter. So say we have a window that's like glazing type D. We can choose glazing type T. And then we can input our total whole area for the window. So let's say, for instance, we have in total a large window set. We maybe have 50 square meters. And then this will give you typical values for these 4 properties based on that window type you've chosen and the whole area you've input. And again, we can copy this one and paste special back into our glazing tab. So that's 2 ways you can define these 4 properties. Or alternatively, you can just calculate it yourself. If you have something unusual like a circular window, you might have to calculate those properties yourself. After that, we go into the permanent shading. This is shading from things like trees surrounding the building. And there's some typical examples given here. So for now, we're just going to use an average value of 0.23 for permanent shading. And if we had roller blinds, we could add shading values here. But for now, we'll leave those blank. And in our case, we've defined a whole block of windows. It's 50 square meters here. So we're just having one of these window sets. If we had defined here the properties for just one windows, we might have multiplied by however many there were. After this, you'll see presented the installed U value. This is the effective U value of the whole window, including the framing losses, the glazing losses, and the thermal bridge losses, all those interfaces we described. Now you can see this U value is higher than the U value of the glass we have here, and that's because of other losses through framing and through thermal bridges. Now, as I mentioned in previous videos, this one interfaces a little with the wall and door element or the roof element, because this area will be deducted from the wall and door tab to produce a net area. So the net area of the wall is now had that window area deducted from it, and that's what will be used to calculate the losses through the wall. So as we change values in here, it's worth bearing in mind that values in this previous sheet will also be updated. If we increase the complexity level, we will find a number of additional inputs to the glazing tab. So these are values that would have been assumed at lower complexity levels. So we have the assumed U value for the frame, the assumed losses around the thermal bridge at the perimeter of the window, the assumed losses at the thermal bridges at the interfaces between the glass and the framing, a maintenance factor, which basically reflects how clean the window is, and a factor which accounts for the sun rays not being perpendicular for the glass. So you can, if you wish, amend some of these values, but often these defaults are fine. As well as those additional inputs, you'll see a lot more detail on the calculations that have been performed. So that's how we define glazing in the Zebra model. In the next tutorial, we're going to be looking at air and ventilation.